rolling. Welcome. We just did prayer. We're gonna have a daily quiz tomorrow on Excel intercepts and domain range, most of it. And then Thursday is your quest, and we'll tell you what page that goes up to. First thing I want to talk about is exercise. And please exercise your entire life. I know I look at these people running when it's minus 15 degrees and I'm like, what are they doing? It's crazy. Why are they running outside? But in the summer, it's not so crazy, and it's springtime, so it's nice weather. So I challenge you, even if you're not a runner or a walker, it's not that hard to become a runner and a walker. All you do is you walk around your block one time at a slow pace. The next day, you go a little faster pace. The next day, you walk around the block 2 times. And then maybe after 2 weeks, you take a little jog and jog 1 lap or 2 laps. And it's all about habit. It's going to be great for your physical being, your heart, your lungs. It's going to be great or greater for your mental being. You guys need to get away from the computer screen and your cell phones. Okay, even if it's for an hour. That's going to be very, very important for the rest of your life. And it's all about habit. It's a matter of doing it, no matter what, because you feel great afterwards. You don't want to do it. Saturday we went to the track. We don't want to do it. And I tell my kids that all the time. But we do it. We warm up. We do excels. We do whatever variety of sports to make it fun. And we also do a bit of running, which isn't fun. I didn't jog at all until I raised money for MS when my dear friend Teresa, got diagnosed with multiple sclerosis when she was 30. Otherwise, I just sprinted and played games. But it's not that hard. It's just a matter of doing it. Sunday, we went to the gym. We played tons of sports. Yesterday, I didn't want to go for a bike ride. I went for a bike ride and almost killed myself. It was so hard. It was like I was against the wind every single corner. How can that be possible? How can you be against the wind every single second when you go in a circle? Whew, it was hard. Would you rather nap? Would you rather watch TV? But don't, because you need to burn those calories. You need to get those endorphins, maybe, and your brain firing, and you need to feel good about yourself. So you don't have to be an athlete to go outside, but you'll surprise yourself if you just do what I said. Walk slow, walk medium, walk fast. That turns into a jog. You'll be shocked at where you are in 6 months or at the end of the summer. It's just a matter of doing it, you guys. Okay, so having said that, sorry, the whole reason why I just said this because our counselors have opened up a contest, I guess, but I think it's more an initiative of getting you guys out. Some of you don't need this because you were born like I was and you ran around the hospital until they could catch you. That's just the way I was wired. However, this is challenging you to do 10 kilometers of anything in 10 days. Whether you walk, jog, bike, skateboard, anything active and outside. And you can win a $50 gift certificate from Sport Check. But again, I like this more for do this for the rest of your life. Okay? Do it for you. Do it for your kids. And do it for your grandkids. Because there's nothing better than being a dad. Although I've heard being a grandparent is pretty fantastic as well. You don't need to get that to KO or PJ. You can give that to me, and I'll deliver it to them gladly. Okay, you start that as whenever you want to. And you can run 10 kilometers one day if you want, and you're done. That's how many times around the track? 10 kilometers. How many times around the track is 1 kilometer? 1 is 400, 2.5 times 10, so 25, laps around the track. If you want to do it in 10 days, walk 2.5 laps around the track or around the block, whatever. Just do something and get, if it makes you go outside, bring your cell phone, but I wouldn't use your cell phone. I don't listen to music or anything when I run. I just pray and think about life. And you need some time where you have no noise in your life, no distractions, just peacefulness and renewal. Okay, hi. Perfect. Do 100K in 10 days. Yeah, you can just put in 1 day if you want to. That's awesome. But like I said, challenge yourself, and there's no better time to get this challenge going at the beginning of summer. Love to see you at the track. We'll be at the track all summer, me and my kids. Okay, 417. So this is your page 16. That's correct. Your XY intercepts, because that's a very important concept. And I'm going to look at 3, and I can bump this up. I can afford to bump this up to 100. There you go. You had most of these. And please, oh, they did write the XY intercepts as points. Good for them. And there's one more G. Don't forget to put, it's like E, square root of 25 is positive -5, not just 5. Podcast people, I'll let you look at this and pause, and you can unpause when you're done correcting. This is page 16 in your hand. Now, I'll show you one more thing if you want to do this for XY intercept. If you're finding the X intercept, that means there's no Y part. And you can just cross off because Y equals 0. So you're solving 4x plus 16 equals 0. If you're finding the Y-intercept, there's no X part. So you're just solving that. If that is easier for you to visualize, that's fine. But for the X-intercept, Y equals 0, solve that. For the Y-intercept, X equals 0, well, that's 0, 0. Now, what you should note about F, if I gave it to you, is if you have 0, 0 as an X-intercept, it is also a Y-intercept because the origin crosses both the X and the Y-axis. It's the intersection of the X and the Y-axis. So 0, 0 is both the X and the Y-intercept. So there. Any questions on this guy? Okay, 2 domain and range on page 21. May have passed that French quiz, I may not have. When we have ordered pairs, the squiggly lines, just the X parts and the Y parts, and you don't have to repeat them. We saw in B to write a number in between -4 and 4 for domain that goes left. It's, you write all the values of X such that, and if it's between -4 and 4, you write it like this with less than or equal signs, and X is everything in between, all real numbers. We saw it all on the last one. Well, the answers are done right here. The domain, if it goes forever left and right, is all real numbers. That's how you say all the numbers in the whole wide world. If it goes from 4 down, I think Nathan's figured out on his own, you say that Y is less than or equal to 4. If it was the opposite way, for this graph, you would say Y is greater than or equal to 4. Okay, so generally, facing down means less than or equal, going up means greater than or equal. And you have to get the right signs. Let's remind you that less than or equal is this one. I was taught it looks like an L. If it doesn't look like an L, this is greater than or equal. So don't guess, you have to know which one is less than and which one is greater than. Or you do the alligator teeth, chomp, chomp, chomp. all that fun stuff. Your page. Example 3. Domain and range. These are delicious. Love them. Okay, so remember domain goes x, and where does your x-axis go? It goes left and right. So make sure you know for domain, all the values of x that are possible, going from left to right, or the width of the graph. And the range means y, and the y-intercept goes vertical, up and down, or the height of the graph. Okay, so let's talk about the domain for this one. You might have a guess. I might even let you think about it for 10 seconds before I do. So let me sit down way over here. What would the domain be? Don't say anything. Of A. How far left and right does that graph go? What's the width of that? Okay, now what you need to know about parabolas is they go a little further left and a little farther right, and forever. Okay, so if it has an arrow a little farther right, eventually it goes to infinity and negative infinity. Okay, so the domain is all the values of x, such that x is all the numbers in the whole wide world. The width of that graph covers every number on the number line on the x-axis. I'll give you another 10 seconds to work ahead of me if you want for range. Take your best guess. Ask for hand signals if you're not sure. Range are all the values of y. And how do you write down -3 and all the values above -3 to infinity? Anybody want to try? Thank you.
Range equals y, so that y is greater than or equal to -3,
Yep.
and y is an element of real numbers.
Good. Perfecto. Yep. Just make sure you get the sign right. If you put less than, I can't give any marks. So again, it's pointing up, so greater than, pointing down, less than. All right, again, I'm going to move slowly. See if you can do the domain for this graph. All the numbers from where to where. How do you write it in math? Any questions on A? They get a lot easier than when you start. I'm not saying they're easy, but they get easier. Need help with domain and range or x, y intercepts or anything else? Lunchtime, we got math help. So domain is all numbers from -2 to 4. If you look at it carefully, so how do you write all the numbers from -2 to 4? Well, you go from -2 to 4, you put the x in between, and less than or equal signs, where x is an element of all real numbers. This means that -2 is the lowest number x could be, and the highest number it could be is from 4. So that means all the numbers from -2 to 4, which is exactly what the domain is. All right, I'm going to just simply let you do the range on your own now, knowing that it's the y values and the height of the ellipse. Don't look into that ellipse for longer than 1 second. You're going to hurt your eyes. David. these glasses.
Yeah, let's do 2 pizza.
Lucky for you. Fortunately, we kind of share. So I'll wait for you. And my math spot up, I can't even see. No, you guys would have glasses. Granola bar, that's actually a chocolate bar. Yes. Okay, the Ranga is from -3 to 1. So how do you write down all the values of y from -3 to 1? The other thing is don't write down the reverse order. Always go from lowest to highest, or you won't be able to write down less than or equal signs. Okay, and that's how professional math students write it. So let's write it that way, from lowest to highest, where y is an element of real numbers, so all the fractions and decimals in between this blue line. Try C, your domain and the range. Let me put another number to make this even harder. Okay, domain and range. This is just like the order of pairs. Mapping diagram. Values of x are on the left side, values of y are on the right side. However, the number I wrote in does not count because there's no value of x going to it. So if you have a number that isn't related to an x, it's not part of the range. Domain is simply 1, 2, 3. Ranga is 2 and 6. Even if I put the 7 there, it's not part of the range. There's no x coordinate. Gives you that output. Now, I like this as a challenge for you. And I'll give you a hint, which probably I don't have to. You don't have to draw a diagram. It certainly helps a lot. I don't insist you draw one, but you're going to make a lot less mistakes, and it's going to be a lot clearer if you do draw one. Okay, so do D, please. Thank you, Maria. So start by drawing a graph, plot the point. From there, you should be able to figure out more of the circles. Try to do it before I do it. Even if you get it wrong, you'll remember it better. Podcast people pause. I gotta take attendance. Okay. So let's draw the diagram. -2, 3. There's 2 left, 3 up. I think I drew it too high. Oh, 2 and 3. So right there is -2, 3. So it says radius of 3. Next time I could say the diameter of 3. So make sure you know what the radius is. Radius. Which one's the radius? Top or the bottom? Okay, so radius is from the center to an endpoint, and the diameter goes from one endpoint to the other endpoint through the center of the circle. So that diameter is twice as big. So here you're looking at 3. The radius is 3. So 1, 2, 3 to get to the other one. 1, 2, 3 to get to the other one. 1, 2, 3, and there's your circle. 1, 2, 3. So now you got to find the domain and the range of that perfectly circular circle. Couldn't have drawn a better circle. It looks like an upside down pear. Anyways, know that this is -2 on the x, so what would this one be? If it's 3 to the right. Sorry? 1? And then what would this one be if you go 3 to the left and -2? Okay, so is that their domain or range? That's the domain. So domain is, this is for the pair question. Domain is all the values of x such that -5 to 1, and x is an element of all real numbers. Anybody get that? Okay, so what did we do? We just kind of added 3 to the x, and I should have put green, oh well, I'll just put red. So you add 3 to the x, and you subtract 3 from the x. So you don't have to draw the diagram, but it helps, it's helpful. So,
For that, do we have to like the greater than and less than, or can we just list like the numbers from -5 to 1?
no, because it's all the numbers in between. It's all the fractions and decimals in between. It's not just whole numbers. Okay, good question. The range goes from, what is it, 3? So this is 3 to 6. So 0 to 6. And we get the range is all the values of y such that like that. Check. We got that. Okay, and again, you could just add and subtract 3 from the coordinate they give you, so you don't have to draw a diagram. I don't care if you do. It's up to you. It's certainly safer to draw the diagram, but not impossible otherwise. Okay, you have homework. Work on your homework on the next page, and then we'll talk about interval notation, and then add on to page 21. So homework on page 22, 23, maybe 24, and 25. 22 to 25. You go. So let's say that. Go ahead and just add this on the top of page 22, podcast people. We also talked about if a graph is going to the right. In fact, I'll even give you an example here. If the graph is going to the right, that means the domain is x is greater than or equal. If it points to the left, the domain is less than or equal. Just like if the graph points up, the range is greater than or equal, and if it points down, the range is less than or equal. Pause, pause, pause. Okay, podcast people, thanks a lot for telling me that I record when I taught. So we're doing interval notation. So let's go back to page 21. And before, when we did stuff like this, oops, I'll just put less name for that. Period equal -7. This is called set notation. So we've done set notation. Now we're doing interval notation, which we already did and I forgot to record. So when you have interval notation, it's easier to make the domain from all the numbers from -4 to 4 in the whole wide world. That's how you write it, with square brackets. Square brackets means it includes -4 and 4 in the endpoints. If it didn't include -4 and 4, it would just be a hollow circle. It wouldn't be filled all the way in. And then you would use circle brackets. Similarly, the range for this one is from 0 to 4. That's how you would write the range in interval notation. If you look at C, the domain goes forever left and forever right. And this is how we write that, all numbers in the whole wide world, in interval notation. Now you can't use square brackets with infinity and negative infinity, is you can't quantify it. So you need circle brackets anytime you write infinity and negative infinity. The range for this one is from 4 down. So if you go from the lowest to the highest, it's from negative infinity to positive 4. And one has a circle bracket, one has a square bracket. Now we're doing example 3A and B. You can pause because we're ready to correct this in class. And now we're going to move on. Podcast equal pause until you're done A and B. So domain for integral notation. Who wants it? What's someone in the middle? Look at no one's looking at anything. Eye contact. That's good. I'm still going to do this. Yes, sir.
Bracket.
Perfect. Fun. Super duper fun. What's the range for this one? Same guy. Okay. All done. So negative 3 and up means that in interval notation. Super duper. What's the domain? Remember, domain means the x values. X coordinate is left to right. So what are the values in interval notation for the domain? Olivia? Yep. Yep. Perfect. If you didn't get that one, I'll give you another 10 seconds to do the range before we do. What's the range, Hudson? Yep. Perfect. Perfect, perfect. So I'll show you when you have a circle bracket when it talks about a number. We're going to have homework on this, and you can see some of them. This one here has points that are not filled in. So is that a square bracket or a circle bracket? So that'd be circle brackets, okay? That's the only time you're going to use circle brackets for numbers. When you have a notation like that, that means this does not include the endpoint if it's not filled in. All right. Now it's Xbox time. Love it, love it, love it. Page 27. Page 27. That's not page 27. Is this page 27? This is page 27. Get your Xboxes out. And that's graph. Okay, we're going to sketch and find the x and y intercepts with our calculator. Sweet. We're going to put y equals -3, subtract x in our calculator, so press y equals button. -3, not subtract 3, so -3 subtract x, which is beside your green button. Press graph, and if it doesn't look like this, press zoom 6. Now when you sketch it, I'm not looking for a lazy line where you do it in 5 seconds. I want you, and I don't think I can write this, I want to see if you have an x-intercept and a y-intercept and then connect the dots. Okay, so your best thing here is right here and here. That's what I want to see. And then you can connect your line and label it. We're going to get a line, a graph like that. If you don't have a graph like that, press Zoom 6. Write down Zoom 6, resets Windows. Where's your zoom button? Top middle. Zoom, the number 6 will reset your windows. If I press Zoom 6, your window will become this. -10 to 10 from your X and -10 to 10 on your Y. So just a standard graph paper. You might have to zoom in or out, usually out. If it's not, the graph doesn't appear on your calculator, it just means it appears somewhere else on the graph, not from -10 to 10. Okay, go ahead and graph this one. Let's just talk about sketching first before we throw too many things at you at once. Go ahead and sketch B the best you can. Y equals -3x subtract 1. You know what? I'm willing to go the next 2 sketches. Go ahead and do the next 2 sketches. Let's just work on sketch. So show me where the x and y intercept is and then just connect them. As opposed to looking at it and drawing it. I'm not looking to take marks off, but if you draw this, and you can see that this XY intercept is not even close to where those XY intercepts are. So start with the XY intercept and then connect the dots. Is the best way to get full marks. Y equals clear -3x subtract 1. Yeah. Ooh, that's a tough one. That's a tough one. So this one is hard to sketch with XY intercepts. So I might just go, this distance is about that much. And this distance is maybe a touch bigger. And then draw best I can. So if you can't do XY intercepts, then just do the spacing of the arrows from the X and Y axis at the top and bottom, or left to right, depending on the graph. Lastly, 2x subtract 5, so clear. 2x subtract 5. If you don't clear this one and you just put 2x subtract 5, there's probably going to be another number left over there, so you don't want to do that. And then this one, okay, so the x-axis is about, or the y-intercept's right about there. The x-intercept is right about there. Now I just connect those dots. And we'll learn how to sketch that in times even faster than the calculator when we know that this is the slope and this is the y-intercept. Alright, so for run. Okay, sketching good? Yup. Full marks, here you go. Let's do the easier one of the x-y intercept. So let's go back to this equation, put this in your graph. And the y-intercept is the value button. That's what you need to press, is calculate value. You're going to press calculate for all of these. So let's do the y-intercept. Don't confuse you. We'll go back to A. So y equals -3. Subtract x, I think it was. Graph. You got to press graph. And then you press second calculate, which is beside the graph button. So when you press second, this trace button turns into calculate. So second, calculate. And then value. And for y-intercept, what does x equal? You put x equals 0. And then you press enter. And it gives you 0, -3. So go ahead and do the y-intercepts for the other two. So second, calculate value, x equals 0, and write it as an ordered pair, please, because the intercepts are points. Do not write down y equals -3. That's a horizontal line at 3 down. And you guys might as well put your Xbox, PlayStations on Kijiji. You got everything you need in the palm of your hands with the TI-83 Plus. Even sounds tougher than an Xbox.
Where would the y-intercept be if it traced exactly the axis?
Depends on whether it's vertical or horizontal. You would have one of them. Oh, I see what you're saying. So it's you'd have 0 of them. Okay, so if it's a horizontal line, there'd be no x-intercept. What would those?
What I mean is, like, if the horizontal line is exactly against the x-axis.
Okay, so it is the x-axis. Okay, so y equals 0. So that they would all be x-intercepts. Every single point would be an x-intercept on that line.
So would it just be infinity 0 for 1?
Yeah. So you're talking about, okay, you're gonna graph y equals 0. What's the x-intercept? Yeah, every single point on the axis would be an x-intercept. And every single point of that line would be an x-intercept. Great question. Awesome bar, it's yours. Okay, so let's go to this one and write the y-intercept. Y equals here -3x subtract 1 graph. You go second, yellow button, calculate right beside the graph, and then value is your y-intercept. X equals zippo. You might get 0, -1 here. Yep, what'd you get for that one? You say 0, -5? Yeah, I can look at it actually, and it gives you 0, -5. Okay, that's the easy one. Though x-intercept is more to it than that. So pay attention, pay attention, pay attention. The x-intercepts, their nickname are the zeros of the function. Okay, so you have to press calculate 0. Now first, let's put this into our calculator. We'll go back to A. Y equals, clear, -3, subtract x, graph. Now, first of all, you need to know what the x-intercept, or where the x-intercept is, because you have to go left and right of it. So you have to know that this is the x-intercept right here. Okay, so you're going to press calculate 0, and then you're going to go anywhere left of it, and then anywhere right of it, and then press enter again, and it will give you the x-intercept between the 2 points that you pressed. Okay, so you go second, calculate 0, because x-intercepts are known as the zeros of the function. And now it's the saying, go left of your x-intercept. So your x-intercept is right here. You got to use these blue arrows to move your cursor anywhere left or above this x-intercept, and then you press enter. And now you move to any point to the right of your x-intercept and press enter. Now look at this interval right here. you can see that your calculator is now evaluating from here to here for an x-intercept, because there might be more than one x-intercept on your graph. Now you just press enter again. If it says guess, press enter, and it gives you the x-intercept, -3, 0. So second, calculate 0, then left and right of the x-intercept, and you move it with those blue arrows. And then you press enter when it says guess. Okay, so go ahead and try these two. And I think I'll do both of them for you, because this is a little harder than just calculate value. But once you get the hang of it, it's your favorite game. See if you can get the high score. All right, let's do B. Y equals -3x, subtract 1, graph. Where's my x-intercept? Jeez, I can't even see it. Ay, ay, ay. It's over here. It's barely over there, so it should be easy enough to go above and below it, though. So second, calculate 0, so number 2 if you want. Left of it, anywhere left of your x-intercept, so that's safe. Press enter. Anywhere right of your x-intercept, press enter, and press enter again. And write that as a fraction. Hopefully you know it. -1/3, 0. If you don't know it, your calculator will do this. Okay, so look at what we have here. We have an x-intercept. If you want to convert this into a fraction, you have to get off the graph. Everyone pay attention. You have to get off the graph. Second, quit. Then if you press x equals, it will give you your x-intercept. And then you can go math, fraction equals, and that will give you the fraction if you want. If it has a y, and y was 0 here, you can also do the y. What's y? Second. Where's y? Is that a y? That's a b. I want to say plus sign. Nope. What is it? Second one? That makes sense. Oops. So second one, alpha 1. Green 1 is your y, and obviously that's 0 on the x-intercept, but you can do the same thing if you want to convert your intercepts to fractions. Okay, go ahead and do this one. Hopefully that's a little clearer for you on the x-intercept. I'm doing this in my head. It's 2.5 5/2. I put x intercept y equals 0 and then solve for x, add 5 divided by 2. You can do it almost quicker than your calculator. I love mental math. There's y equals, clear, 2x subtract 5, graph, and there's your x-intercept, so you go to the left and right of it. So it's not always above or below it. Last time we started above it, well, we're not starting above the x-intercept this time, we're starting below it, so it's to the left of it. So second, calculate 0. Left of this is anywhere below it, and then right of it, anywhere above it, and then press enter again between that interval. It gives you 2.5. I'm going to put 2.5, 0. And please write it as an ordered pair.
What if you were to write it as 5/2? That's fine.
That's fine. But better 2.5 when you're graphing and talking about 2.5 units to the right. Easier to plot when you don't have 5 halves. Do this one. Sketch it. X-intercept, Y-intercept. And then we'll talk about some football on page 29. We'll do a word problem with our graphing calculator. So page 27, I guess, just one question. You might be done already. And D is the only one we haven't done. Just for an extra step or an extra practice with your Xbox. Y equals 5. Means 0, 5, 1, 5, -3, 5. Anything that has the y coordinate 5 at the end is 5 up. I'm doing this without a calculator. So where's the x-intercept? What are you going to put? Okay, so you're going to put no x-intercept. You're not going to leave it blank, because leaving it blank doesn't give me an answer. That just means you didn't do it. And you're not going to put 0, because this is 0, 0. So don't put 0, and don't put blank. You have to tell me there are no x-intercepts. What's the y-intercept? 0, 5. And I'm sure, what does it say, error when you do your x-intercept? Well, there's no x-intercept to go left or right of. So that's just, you're not either common sense. If you don't have an x-intercept, you don't have an x-intercept. Okay, let's play some football on page 29. And we need to punch this relation in our Xbox. So go to your y equals. Y equals. Clear it. Put -5t squared. Except for you're not going to put t. It's going to be x. And then x squared. And then plus 14t plus 1. Press graph. What did I do? -5t squared plus 14x plus 1, graph. Why does it say quick? I'll press zoom 6. My calculator has just gone wonky. Alright, I'm just going to reset it. Second addition sign, 712. Mode degrees. Y equals negative. I couldn't have pressed, maybe I pressed subtraction sign. That would have been weird, as I have never done that in my first 87,000 times. Plus 14x plus 1. Okay, graph. We get something like that. Okay. So, that's not the graph we're looking for in real life. Because what can you tell me about time and distance? This is quadrant 1, 2, 3, and 4. What about kicking a football in real life? What can you tell me about the window? Everyone? Can't be negative. You can't have a negative distance. You can't have negative time. So you're going to change your minimum to 0 and your y minimum to 0. Okay, so let's write that down. And all you have to do is show me that once. That's your window that you're now on. 0, 10, 1, 0, 10, 1, and 1 for graph. And that looks more like kicking a football.
You can kick a football backwards, can't you?
Yes. Well, I can't, but maybe you can. My kids have been doing that lately. Especially in high school football. Lots of mistakes. Sketch the graph. So, what do you see about our graph? The top is cut off, right? So we want it higher. Press your window. How do I make it higher? Is that X or Y to make it higher? Okay, so let's go and change your Y max to 20 and 2. So write down that window, 0, 10, 1, 0, 22. Now press graph, and you should be able to see the football leave the foot and then land on the ground. Yay? Right there. Now you notice we don't have to have 10 seconds. It's actually hitting the ground at 3 seconds. So if you wanted to, we could make an easier graph to deal with, but this is going to be good enough. So go ahead and sketch the graph. And when you sketch the graph to change the windows, you got to tell me that you changed the windows. So I'm not going to sketch it. It's right there. And you can see that it goes, well, it looks like it goes 5 meters high, but remember, we changed the window, so every unit on the y-axis is 2, 4, 6, 8, 10, so forth. This is 1, 2, 3 seconds, it lands. Now, what was the height of the football above the ground? So let me actually deal with this. It's important to know how you draw the sketch, okay? Oops. This goes kind of like that, I hope. So B says, where's the height of the football above the ground before you kick it? Well, you should be able to mark X on the spot. That means this point right there. What do we call that point? The y-intercept. So this means find y-intercept. So go ahead and do that with the value button. And now we are translating x, y-intercepts into answering word problems. So you go to your graph, you go second, calculate, value, x equals 0. And it was 1 meter high, which is a meter stick. So meter sticks go up there. That's kind of where you drop it. I guess he's taller than I am and has more flexibility than I do, because I would kick that one backwards. Okay, F. And be careful, this is nearest 100. Hits the ground. Well, mark an X on the graph where it hits the ground. That's this. What is that called? X-intercept. So this is saying find the X-intercept, which means 0 button. So go ahead and find the X-intercept and use your reasoning to figure out what to do. I'll show you in 44 seconds. And you'll probably figure it out. Looks like that's a bit. Okay, so second calculate 0, I gotta go left of where it lands. So anywhere above the ground. I'm gonna press enter. I could have pressed enter right away, I just wanna get closer. And now I have to go right of it, so where do I go? I've gotta go somewhere under the ground. You can tell I'm under the ground here at y equals -1.6. Press enter, and then press enter again. And it says nearest 100, so be careful, it's not 2.9, it's 2.87. Is it meters or seconds? What's your x? Put your x as time. That's what we forgot to do. Can you guys add the axes, please, into your graph? Time and height. And this is x, so x is seconds, time. Even tells you how many seconds. Okay, next question is Z, maximum height of the football. We did this kind of yesterday. Go ahead and try to find the maximum height of the football. Now, I'm only going to give you 10 seconds because it just looked like we were running out of time. Graph. Second, calculate maximum. Okay, you're going to press 4, and then you go left of the highest point. Anywhere left of the highest point, press enter. Anywhere right of the highest point, press enter. And then see if they ask you to nearest tenth or nearest 100. So 1.4, I didn't ask anything. So let's just put 1.4 meters. That can't be right. Is it 10.8? Oh yeah. So at that, after 1.4 seconds, it reaches the height of 10.8. Thank you. So that could be a question. 1.4 seconds equals 10.8, you say? Meters high. So the next question after maximum height I'll ask you is how long did it take to reach 10.8 meters, and that's the x coordinate, the time. All right, wash your desk. God bless on Sunday.